So this is a brief introduction to Git. There's a much more longer version of this presentation that goes into excruciating detail on how to use Git and the different commands. I'm just going to go over some of the more common concepts. Okay, and if I'm sure you've already gone through Git. I'm sorry if this is going to bore you a bit, but I just want to make sure we're all on the same page. So Git is a source control management system. If you have a Mac, you probably already have Git installed on your machine. If you have a PC, you might need to go and install it, download it, and install it from Git SCM. And there's several versions of a client that you can install to communicate with GitHub. We are going to be using the GitHub for the college, not GitHub.com. Okay, so Git works in the idea that it's a distributed source control system. Okay, and that it doesn't actually have copies of files. Instead, it has a history of modifications. Right, it starts off with a baseline of a file. Right, and then it keeps track of how that file has been modified over time. That you've added this line, you've changed this, that, or the other, and then it can calculate with the current version of that file. Right, starting from the initial one plus all the history of modifications. Okay, and then it keeps track of different staging areas. Right, you have your local working area. Right, where you have the actual physical files, current files. It also keeps track of a staging area it has a specialized directory, right, called Git, right, or .git, and under there it has all the history is stored under there in that directory. Okay, so in your project, you will have a .git directory where all the history is in there, and as you create files or modify files. Git doesn't know if those files it should keep track of them. You need to tell Git, right, that keep track of the following files, right? So we add them, right? We use the command git add to add files to the repository, and once they're added to the repository, Git keeps track of any modifications, right, of those files, right? Whether they're brand new or we've been modifying. Those files. Any modifications are kept track in a staging area, and it highlights all the things that have been modified, right, in the staging area. Not until we commit and say, okay, I'm fine, I'm done modifying this file. You can commit and put a comment on what it is that you've been doing with this file. It makes it permanent in a local repository, right? And as far as I'm concerned, this is my source of truth, right, in my local little environment, right? But typically, what we do is that we agree in the team. We agree that one of us, or at least one particular machine, is going to be the one source of truth of all the files for the team. Okay, so as far as I'm concerned. I'm the one that has the latest truth, right? And then I push my changes to the repository, and then I notify everyone else that they should pull the latest truth, right, and merge and have a copy of that in their own local repositories, right? And as far as concerned, now we all have the same copy of that's the same source of truth. Yes? And as everybody progresses and makes modifications, they put it to the staging area, they put it to the local repository, and then they push it to the remote machine, and then they notify everybody else to copy and pull down all those changes, so that hopefully, we're all progressing from the nearest version of the truth, of the centralized truth. Make sense? When we get notified and want to make sure that we are in sync with a centralized version, we do what is called a pull. We do a git pull, right? All the commands start with git and then a verb, pull. You either send versions up to the remote cloud, doing a push, or you do a pull and copy back down from there. So the syntax of all commands, they all start with git, and then the verb, you can add files, you can push files, you can pull files, you can merge different branches, and then the options and the paths, right? And there's a plethora of different options and different ways of doing the same thing. Please read through our slides and do it the way it's documented here. Right? We just want to standardize how we work throughout the if everybody just does anything what they want, we'll just have anarchy, and it will make it really, really hard for the TAs to grade and have a consistent, repeatable grading. So please follow the instructions in these slides. Yeah, so the first thing is that we add the files. If you don't add any file, Git is not aware that it's keeping track of anything. You can add the files when you first create the files. Once you've created the files and you've added them, you don't need to add them again. You can just modify them and just commit those changes as you modify them. But any new file needs to be added explicitly to the repository staging area. And you can add multiple files by using git add dot. Right, everything that's brand new that you can find that is not already in the repository will be added to the repository, right? And there's all sorts of options that allow you to add files or remove an existing file. Maybe you're telling Git that I don't want you to track this file anymore, right? I just want to remove it, or add things that have been that have only have modifications or only have had deletions, and you can filter the things that you want to add to the repository. Once you've added to the file to the repository, you can start making modifications, right? And you can ask the status of a file. You can say git status, and Git will let you know what have you modified lately. What are the latest modifications? We'll highlight the new lines in green. We'll highlight lines that you've removed in red. Right, it will highlight any changes, new text that you've added, and there's certainly there's plenty of nice user interface clients that allow you to do this, and you're certainly welcome to use this after this assignment. This assignment asks you to do this all at the command line. Right, it's like we're learning how to add and subtract and multiply by hand. And once we feel comfortable with that, we'll give you the calculator, and then you can use the calculator. But first, we're going to do this all by hand, right? Just to get a feeling for it and make sure that we understand. So once you're done with modifying the files, you can commit and give a message, a short description on what is it that you did, what did you update, what did you modify, and this gets committed in your local repository. And finally, once you're done, you do a git push. And git push to the remote repository, and it copies your local changes to a centralized version control. Right? We notify everybody in the team, and the team does a git pull, right? And copies all those changes onto their own personal working repositories. There's a plethora of commands. Log allows you to do a quick list of recent modifications, right? That I've made, that other folks have made. Right, so I can take a look, and I can ask for differences, on my current file, local source file against what is in the current repository to see how far have I strayed from what's there, what have I modified lately. You can initialize a repository if it's a brand new directory and this is not yet a Git repository. You can initialize it. You can move files. You can clone repositories that are already there. This is the first thing you're going to do, right? With the repositories that we've been giving you, right? You're going to clone that, git clone, and the URL that you should have received, and you clone it down. It'll copy it over to your local repository. You'll configure your usernames, your passwords, your email. There's all sorts of configuration properties that you can configure. This is just a snippet, git config, and then user.name, user.password. use that email and things like that. You can list the current configurations, and there's different levels at the particular directory that you're in, or global, right? That are values that are for multiple projects. Git ignore. You'll be asked to create a git ignore that will contain entries such as log and .class files, jar files, war files, ear files, right? Zip files. Remove. We don't want those to go into source control. Branching is a mechanism that allows you to work on a particular feature. You should never work on the master branch, right? The master branch is where we start, okay, and we branch off of that, creating a branch. We do all our work on that branch, and once we feel comfortable and we've tested it and we've done all sorts of dumb things and that we've fixed, and we have other people's input, and everybody agrees that source code is really good, then we ask for it to be merged. And you will not be the one who merges, right? We're going to assign to someone else, right, to review this and merge it. It's somebody else's responsibility. So we'll first create, there's a master branch. Off of that, we're going to create various branches, right? And we're gonna work on that particular branch. While we're working our own branch, the master branch is progressing, right along. Other folks are working on their own features, right? And they've been committing, all right. And the master branch, the remote master branch, has been kind of moving forward, right, ahead of me, and I'm risking straying too far away from that master branch. I need to, frequently, every time the master branch is updated, to just pull that, right? So always making sure that I am synchronized with the master. So as I'm working and I see that the branch has gone forward, I would pull and merge into mine. Pull and merge, making sure that my code is in no conflict with the master branch. And if there is, I need to make sure that I resolve that divergence, that conflicts, right? Once we're done, I would create a pull request in GitHub and assign it to someone. Someone would look at it, would accept this as, oh, this is great, right? And they will be responsible to merge it back into master. They're taking the responsibility as if they would have written it. So this is a big responsibility. It says I didn't write it, and I'm becoming responsible for that. That's a big job, right? This is, are you sure, right? So again, we try to make small commits, small chunks, something that we can actually together review it in a day, in a couple of in a half an hour, and come to a conclusion that it's good, right? To manage branches, we can use Git branch, and that will list all the branches. You can create a brand new branch by saying Git branch name. Typically, the first thing that you do is before you create a branch, you make sure that you are in sync. You do a Git pull. You do a Git pull and make sure that you are in sync with the very latest from master, and then you branch off. Git branch, and you create a new branch. The name of that branch typically will have a very specific name, right, based on some requirements, some feature, right? Typically, perhaps it starts with some number, right, or some naming convention, dash, some very short description of what is it, so that a human can read and understand what it is that it's about. You might have multiple branches. Perhaps you're working on a feature, and somebody says, there's a problem in production that needs to be fixed. Right? Says, okay, well, I'll leave that. I'll go back to master. I'll pull the version where that was deployed in production, right? And I'll create a branch while I fix that bug, right? And once I'm okay, I create a patch. I assign to someone to merge it into production, and then they merge it. It gets deployed, and then I can do and switch back to the branch that I was working on, right? I can switch back by doing git checkout in the branch that I want to go back to, my feature branch I was interrupted, right? And I keep working on my feature branch, right? So I can have multiple branches going on. with different versions of the software. And you can also ask differences. How far have I strayed from master? And you can compare different branches. And then finally, somebody merges. You can go into your branch and say merge that other branch, master, and merge it into this current branch that I'm in. So merging branches, there's always the risk of conflicts, right? And what Git will do is that it will highlight where those conflicts are, right? It'll say, it will add additional lines and that before, in the middle, and after where the conflict occur. It says this is what you have locally in your machine, and this is what you have what's currently in master, right? And it's asking you to make a decision. Do you want to keep yours, or do you want to keep the one that it's in master? Which one is it? And perhaps both should be there, right? But it's your decision, right? You would remove those additional characters that it adds, right? And decide whether it's yours, whether it's theirs, or some combination of both, right? But it highlights where it's not sure, right? Typically, the Git will make a best effort at merging things automatically, right? Where there are no conflicts, right? Where you have modified code that no one else has modified. Then it will do an implicit merge and say, oh, yeah, I could certainly insert that source code in there. No one else has touched that, right? So you are working. It's like you have a Google document, right? And you're working way at the top of the Google document, and I'm working way at the bottom. There are no conflicts, right? We can both work simultaneously. But if we're both working on the same paragraph, then it's a different issue, right? We have to decide how we're going to merge our changes working on the same sentence, right? So Git will automatically merge things implicitly that do not conflict, right? It will only generate a conflict where it's not sure. And say, well, you both touch exactly the same line of code, right? So which one is it, yours or theirs? So it's your responsibility to handle that. Once you're done making your changes, you can commit to the repository. If you want to change something, perhaps the message, you can amend a commit. You can revert if you see that you've been working on this file and it says, oh my goodness, this is awful. You can always go back to the original version of the file by just checking it out again. You can say git checkout and the original file. It will override whatever changes you have in your local repository. You can reset head, meaning it keeps a history of all the commits, right? Yours, everybody else's in the team, right? And you can get a list of all these commits by doing git log, and it will list them all. And perhaps you might have found that a particular way that you guys had gone it actually was a bad idea, right? And you can always just jump back to a previous version, right? And you can tell it, there's the list of all the commits. I want to go back and jump back to a different version. You're kind of like going back in time, right? You can jump anywhere in the history of the source control, or you can reset it and just throw away everything that you've done and just go back to where the master pointer head of the top of the history is, right? So you can just throw away and go back to a previous version. The git reset allows you to jump around into different in the history of the commits, and you have different varying types of resets, of which they have varying degrees of not being able to undo those resets, right? You can have it change the staging, change the local repo, or change your working file, the ones the physical files that you have. That would be undoable. You cannot undo a hard reset. But oftentimes it does happen that somebody paints himself in a corner and says, "Oh my God, I just want to just start all over, just throw away as if I had not done anything," right? So you would do a reset hard, right? Just go back to the original. You had modified 3, 4 files, and you have a bug that you can't solve, and sometimes you just say, "I just want to start all over clean from where I was," right? So these commands, pull, fetch, push, allow you to synchronize with whatever is already in the remote repository, right? The centralized master owner of the truth, right? And go back and pull it from where other to where other team members have been pushing, right? All their commits. Remotes. The remote repo is, as the name suggests, is a repository that lives in some other machine, right? A remote repository is any other repository that is not my machine, right? But we typically refer to it as a remote repo as one particular machine, right? That is, its only task is to have the one source of truth. Okay, it's no different than anybody else's remote, right? Any remote outside of my machine is a remote repository. But we have all agreed that one particular one is the one that has that we've decided is our one single truth. Okay, so that's what the TAs have created for you, right? These remote repositories, right? That you're going to be keeping track all your changes there. Git. We're going to be using GitHub, the school's version of GitHub, and it's going to keep track. It has a user interface that allows you to view all the history and interact with other team members, and even has a simple bug tracking and issue tracking tool. Although we're not going to be using Git's bug tracking, issue tracking tool. It's fairly simplistic. Instead, we're going to be using Jira. Jira is kind of like the industry standard of keeping track of tasks. Who's working on what's the current status of what you're working on, whether it hasn't started yet, whether it's in progress, whether it's ready for QA, ready for user acceptance testing, whether it's been merged and whatnot. Yes. So we're going to be using Jira for that kind of work. But for source control, we're going to be using Git. All right, so this is just a small snippet of Git. There is a different version of this that is much goes into much more excruciating detail. That's there's a short, and here it is. It's about 100 slides that we'll make available, and it goes into much more detail on examples on commands and what they would print out, the differences, the removing, and works through several examples on how to use it. Okay. All right.